Hi, and welcome to this introduction of files. We're going to go through a journey. So I'd like to welcome everyone and thank you for being here. My promise to you is to take you on a journey of files like you've never been on before. It's one full of fascination and amazement and of learning new and valuable skills. So let's jump into it. What is a file? Well, there's more than one answer. It's a simple question, but there's more than one answer. So here's one answer. A file is a sequence of 0 or more bytes. And let's create an empty file. So if you go on your repl.it site and in the command prompt, do a touch space myfile, that actually will create an empty file for you. If it does not already exist, it just touches it. So if it's not there, it will create it. In fact, you can use the ls command, and the ls says list the files in your directory, and here I'm doing ls myfile, and you see we do have a file called myfile. If I do an ls-l for the long listing, we see it shows us the file size. So notice there the file size is 0 of this thing called myfile. If you cat it out, that is, you try to concatenate the contents of the file to the screen, notice nothing appears because there's nothing in it. Finally, if you do the file command on myfile, notice it shows that it's empty, which we knew that, but the file command confirmed it. Now let's put something into the file. Let's do echo 123. We redirect the output and it goes into that file. So this is a shorthand on a Linux machine, how you can put some, in this case 123, into myfile. We do ls, we see myfile is there, or ls-l. I want you to notice it now has 4 bytes. So the file size is now 4 bytes. And you can say, well, wait, why 4 bytes? We just put 123 in there. Well, it turns out the echo command also puts on the end of whatever you're echoing, it puts a new line character. And in fact, notice if we do the hex dump with the -C option on myfile, it dumps out the values in hex. So hex 31 is actually ASCII 0 or ASCII 1. Hex 32 is ASCII 2. Hex 33 is 3. And the 0A, that is the hexadecimal 0A, is a \n. Or if you prefer, notice at the very bottom, if you do file, myfile, it shows that we've indeed got ASCII text. ASCII for American Standard Code for Information Interchange. So that's basically the text you see on the screen. So the key thing, when you say cat myfile, you see 123. That's what we as humans look at. But if you do a hex dump of it, that is to look at the file internal and see what numbers are inside that file, it's actually the hexadecimal 31, 32, 33, and 0A. Now, when I do the ls-l for long listing, it shows us what are called the file attributes. And I want you to notice the very first attribute on the left is the file type. And if it's a dash there, it means it's a normal file. So here we have just a normal file. The next 3 sections, it shows the owner, the group, and other. And these are the permissions. So the permissions can be R for read, W for write. And although we don't see any here, that third one, which the dash means you don't have the permission, the third one is execute. So you can actually have read permission, write permission, and execute. It'll have an R if you can read, a W if you can write, or a dash if you cannot do that particular permission. So notice the owner, that is who created this file, which is us, we can read and write it. However, the group, that is whoever is in our group, they can read it, but they can't write it. And the other, which is everyone else, notice they can read it, but not write it. Now also notice we have an owner as a name, so we're called runner, and we're in a group called runner. So a file has attached to it both an owner and a group. Often those will be the same name because the owner will have a group, and in this case the same name as the owner. Of course, we see the file size again, the 4, and we see the time of access, in this case February 19 at 11:23. And finally you see the file name. Now you can also make a directory, also sometimes called a folder. So if you do the mkdir, you will make a directory, and here I'm doing mkdir on mydir, right? You can call it anything you want. I do an ls mydir When I do ls mydir, it comes back as empty because there's nothing inside that directory. But if I do ls-ld, that is, show me a long listing of this directory, notice the very first character in that output from the long listing is a D for directory. So this shows us the file type is a directory as opposed to a normal file. Also, down at the bottom when we do the file command, notice it says myfile mydir, and it says indeed this is a directory. Now, normal files and directories are your two most frequently used file types, and we could actually just move on and not worry about the others, but for completeness, I want to show that there are other types of files. First, there's something called a hard link. A hard link is basically the same as another file, but it has a different name. In fact, notice when I do the ln command, which stands for link, I link the existing file, in this case my file, to, in this case I call it another name. So this is creating what's called a hard link. In fact, if you do an ls-l of both my file and another dash name, you're actually looking at the exact same file. It doesn't matter whether you look at the another name or the my file, they're exact in every way. In fact, if you at the bottom we do an ls-n of my file and another name, both of those have an internal inode, that is an internal link, an internal number of where it is on the file system. That's the exact same, in this case 1,000. Also notice the hard link count. That count actually increments every time someone does a hard link to you. You don't really see these used too often, but I just wanted to mention it for completeness. Another one you see is a soft link. Now these you see a little more frequently than you do the hard links. A soft link, you do an ln with a -s, the -s for soft, and I'm soft linking my file to my soft link. When you do an ls-l here, notice the soft link has a L at the beginning of the file, which means it's a link. So L for link. And in fact, I want you to notice the file size in this case has changed. It actually has a file size of 6. And the reason for that, the file size of a symbolic link is actually the name of the file it links to. So inside of the soft link is the name of the actual file. So in this case, it would be, since it's linking to my file, that's when you see myfile, my file, that's 6 bytes, and so that's what we see listed here. Now there's also something called a FIFO, a first in, first out. This means what goes in first goes out first. It's kind of like a queue. And so here we have a command mk FIFO, so make FIFO, calling it my FIFO. When I do an ls-l, notice here we have a P for pipe. So another way people refer to a FIFO, a first in, first out buffer, or a queue, is as a pipe. Now again, you don't see these quite as often, but I'm mentioning it here for completeness, that you can create a pipe, sometimes called a named pipe, sometimes called a FIFO. Here's another one. Now you actually have a lot of these on your system, but you don't typically realize it because they're kind of hidden from you. In fact, to demonstrate this, I have to write a short C program, which I'll show you here in a moment. GCC-O for output, say put it in this file called socket, and my source code is socket.c. When I run /socket, notice it creates a socket, and I show the output of that. Notice the first character, an S. The S stands for socket. So if you see a file on your system called socket, it means you have created a socket. It's something that can be read and written from like a networked application. Sockets are used for networking, and you can have a local socket, which means you're doing essentially local networking. Anyway, down at the bottom when we do file on my socket, notice indeed it says it's a socket. Again, this is one you just need to know. It's primarily used when you're writing networked applications. Here's the C source code. I won't go through this in any detail, but it's there for if you want it. The key thing is at line 14, we create a socket at line 14. It's a particular type of socket, and at line 20, we do something called bind to that socket, and when we bind to it, that's when we give it a name. So notice at line 19, called my socket, that's where it actually is assigned a name. Okay, there's 2 more to go. There's something called a character device file. This one you don't typically create. They're usually created by the administrator or the system for you. If I do an ls-l on /dev/tty, that first character, C, means it's a character device. A character, it looks like a file, but really you're talking to a device. In this case, a TTY, a teletype device. This is your console, and it's considered a character special device. One of the nice things about Linux is devices look just like files, so you can read and write them just like you do files. And in this case, there's a character device file. A character device is one that you read and write a byte at a time. Last, there's a block device file. A block device file, kind of similar to a character device file in that you're talking to an actual device as opposed to a file, but this one you read and write blocks. So blocks of data come in and out of this. By the way, there were no visible block devices on the repl.it under /dev, which is where your devices are at. So here I'm showing it on a MacBook Air. The MacBook is also a Unix system, so it has the same type of formatting for files. So a summary of these file types, there's a normal file, there's a directory, there's a symbolic link, there's name pipe, there's socket, there's character special file, and block special file. Now I want to be clear, these file types are on a Linux system, so any of these Linux systems you use, the cloud-based systems that are Linux, as well as local systems. They're also on the Mac because the Mac is a Unix-based system, and Unix is what is the foundation of both the Mac and Linux. Where you will not see these is on Windows. Windows has its own different type of file system, has similar concepts, but not exactly like this, unless on Windows you decide to run either a virtual machine that runs Linux or you use WSL, the Windows subsystem for Linux. But for our focus, since we're using this cloud-based repl.it, these are the file types that we're interested in. I would say the symbolic link, name pipe, socket, character special, and block are just for your information. In this course, we'll be focusing primarily on normal files and directories. I'm Norman McIntyre. Thanks as always for watching.